Hello and welcome to the Miko Bits show, and I'm your host, Miko Bits, and today we have Dean from Agoric. He's the CEO, and he's been working on smart contract technology for actually decades, if it's even possible. So, it's pre-blockchain. So, we're going to see some pretty amazing insights, and hopefully we'll get a real good chance to understand Agoric better. So just a quick preamble. It's an opinion show, so it's not intended to be investment advice, but I guess without further ado, hey, welcome, Dean.
Thank you. Good to talk to you, Miko.
Yeah, always. So just a quick disclaimer on my side, which is my venture fund, Gumi Cryptos Capital, is an investor in Agoric. So just want to get that out of the way so people understand the context. But that being said, I think that, it's by itself an incredibly fascinating topic. And I'm just excited to have Dean on my show. Definitely an incredible thought leader in the domain of smart contracts. So I guess first things first, help me wrap my head around the history of smart contracts. Tell me a little bit about smart contracts.
Sure. I usually start with a couple of founders, Markham and myself. Mark did the Agoric Open Systems papers back in 1988, which really was the first big articulation of software agents creating and participating in markets. Then in 1989, I worked on what we now basically regard as the first production smart contract. And this was at a company called Amex, American Information Exchange, where this was before the term was coined. But then a couple years later, Nick had been thinking about all these ideas and pulled together the things that were important about it. And after that got articulated and said, this thing that some people are starting to do, that's really important.
This would be Nick Szabo.
Yes. Nick Szabo, yes.
Okay, go ahead.
And came up with these characterizations. And this was a extended community of cypherpunks where we were sharing a lot of these things, talking about a lot of these things, and observed that indeed Amex was a smart contract for all the intentional reasons of what smart contracts were for and were about and were good for. And so hence the first production smart contract before blockchain, 5 years before Vitalik was born, and working.
And certainly well before the Satoshi Nakamoto white paper, right? So definitely smart contracts and the history of it. I did see Nick Szabo speak at Blockstack Summit. And, it was very educational. He definitely kind of came at it with the whole, it's a vending machine, which really has kind of been foundational to the way I reason about the space ever since then. So, it's great to hear. So, it's great that you've been working on it for this time. I'd love to kind of get your perspective on how has your historical experience informed your way of looking at the blockchain and sure, what's happening now in cryptographic assets.
Great. Well, so I think it's actually important to start with what is a smart contract. And often I'll ask people, okay, how many people out there have used a smart contract? And and especially in a business audience or stock exchange folks or finance folks, there'll be one or two people who are like, maybe I have. There's many. Right. But the idea of smart contracts clearly predates blockchain, and it's really about software mediating the exchange or interaction between third parties. So it's a contract-like arrangement between parties implemented in source code where the execution of that code enforces the terms of the contract. So if there's a payoff or a transfer or what have you, that's done by the software.
But I just want to interject there, which is one of the things I love about the framing and the way you've defined it is that you're talking about enforcement of the contract in software, yes, right? Which is beautiful because that's business, right? And what I mean by it's business is that, the origins of smart contracts as you're describing them is not code, is law, right? Law is law, right? But code is kind of helping automate things to make sure that they work out in a lawful way, right? And then when and if the code does something weird that you didn't expect, then like, you know, then you crank out the contracts and you start getting your lawyers, right? So I mean, I just want to like clarify. So
absolutely, yeah. And indeed, in Amex was a smart contract for negotiating consulting agreements with people in a bulletin board where you could say, I have this consulting problem, who wants to solve it for me? And it had very specific structured elements where, you know, as I submit my contributions to answer your consulting request, I would automatically get paid by the system. And, you know, some of those payments were not disputable. And some of them were. And there was part of the contract that was enforced by software where at certain times the participants could arrange for humans to step in to resolve some element that humans require. But that was in the confines of, okay, the only thing the humans can decide is, does Joe get this money or does Alice get this money? And, you know, and so it allowed this very structured automated cooperation, plus, of course, escapes into normal contract law, normal legal system, and et cetera. And so, yeah, this was all about, you know, providing enforcement in software for business relationships and cooperation that people wanted. And so our view is, of course, eBay, PayPal, Venmo, Airbnb, much of Uber and Lyft, Amazon, et cetera. Those are all interactions among third parties orchestrated and enforced by the software in the middle. In this case, a trusted intermediary, so that's got its own problems, but it is software that's doing most of the decision of, is now the time to pay the driver, or do they get a percentage extra because they got stars, or was it aborted, and if so, I automatically arrange a credit difference, or, you know, all those mechanisms. Most of that happens in software. Right. And there's, yeah, you know, ways to bump out to get a human involved, but most of them happen, are resolved, transferred, rights are transferred, and all that all happens in software. So.
It brings up a really, really hot keyword for me, right? Which is actually two keywords, right? The two keywords that really, really rise up for me when you speak this way are, one of them is protocol, right? And protocol in the most sincere sense of the word protocol, not even this nouveau sense, right? In the sense of like, when you go back to the concept of protocol, protocol is like, this is an agreement about how we do things, right? That's what a protocol is. So when you come back to protocol, it goes beyond this kind of very limited technical definition of a protocol that's kind of enforced by the implementation, right? It's like, no. The protocol is just an agreement of how we do things. You know, the implementation's whatever you want, right? But I think the other word that I think is super big, and I think also is popping in kind of real, true decentralized communication, is coordination, right? Like the word coordination is like this epically important word, you know, and I hope people understand coordination, because like, that's what you're talking about. Like when you're talking about Uber, it's like, Uber is just a mechanism for coordination, right? It happens to be centralized, a bunch of characteristics, but like, I think what you're poking at is well, you know, should it be? Does it have to be? Like, of course not, right? Like, could be anything. You just need the protocol and you need the coordination.
Right. Well, and then, so then there's what, you know, there's so many directions to go with that.
Good, that's good.
Right. So, I mean, because, for example, you know, my original engagement in smart contracts came out of looking at both workflow systems and also speech X work. I was, my advisor was Terry Winograd at Stanford, who was one of the early AI pioneers, and he did a thing called speech act theory with a bunch of.
I ran into his work in the context of Etta Owen. So
okay.
And this was when I was a kid. I was this nerdy kid programmer, and
I got into software by reading his PhD thesis. So,
Winograd, definitely a legend. So anyhow, please go ahead.
But what they were doing, and what all these workflow systems would do, was try to put 100% of the workflow between parties into software and enforce it. And, you know, so that was, you know, precursor to smart contracts. But there were a couple issues with that, which is you can never get 100%. Right. And so if 1% of the time the contract enforcement did not meet what humans needed to do, that meant 1 out of 100 transactions blew up. So, 1% is just not good enough. You needed a mechanism built in to be able to escape to renegotiation or arbitration, or, like the Claro system where you've got dispute resolution of some form. But by focusing on automated the core of the transaction and allowing other elements of it to be outside of the automation and enforcement, that turns out to be a generally more powerful system, right? Bitcoin is a smart contract. It's just one smart contract. It is a software that's enforcing a particular arrangement of coordination, but it's not trying to enforce all of your exchange and trading with someone where the payment happens to be in Bitcoin. It's just giving you the automation for the payment part, and now I can bed that in a more complex process that might involve humans negotiating about a trade that I'm going to pay in Bitcoin, or that might involve other software things that are enforcing the terms of other contractual arrangements where the payment then happens in Bitcoin, and so forth. And so to the economy of smart contracts is where multiple smart contracts can coordinate with each other in various interesting and ad hoc fashions, so that no one contract is trying to think it knows 100% about a particular kind of interaction that people want to engage in, or that companies want to engage in.
Yeah, so I'm very excited about your framing, because for me, one of the things that's always been a truism in computer science, right, is that, like, it's been thought of probably several generations before, you could even consider it, right? So I think that one of the negative tendencies in the blockchain community is the kind of reinvention of various wheels, right? And so, it's a very much kind of, for example, governance, right? Like, governance is fraught with the reinvention of wheels, right? Like, and people just want to pretend, and I think there's a tendency that stems kind of out of historical ignorance, which is that people just think nobody's ever run into this problem before. Now, on the plus side, it enables wholesale resets, right? So that's the plus side.
Yeah.
But on the minus side, like, there's so much intellectual activity that's left at the side of the road, and I think that's a problem.
I literally just gave last weekend, I think, a presentation on pluggable governance. So what Agoric is building is a smart contract framework in blockchain. I can talk about what blockchain brings to smart contracts, but where you get to plug together. I mean, it's a lot more like DeFi Legos than all the systems that people otherwise talk about for that. Where I mean, the reason why React in JavaScript or Vue in JavaScript took off is not I can copy other people's code and their ERC20 rendering component and put it together in my application. It's because I can take people's components whole hog and plug them together with just parameterization. And that's why literally you get this exponential rise of expressibility and programmability, such that amateurs now, with a couple of months training, can do a vastly superior, more interactive, safer, more functional, handicap aware, multilingual application that an expert could not have done 15 years ago. They do it because they're building on the components that those experts produced. And that's a necessary requirement for the real growth of smart contracts. And it's not something that you can get in other systems right now. You get some limited composition of remixing source code, but that's kind of barely good enough and extremely risky. And there's plenty of, there's literally tens of millions of dollars of losses pointing at how that's not the right way to program there. But we need this other model in order for smart contracts to really grow. So this governance presentation was showing how that very same pluggable, extensible model could apply to governance, where, in our platform, the same mechanism that I would use to vote for a on-chain governance action, I should be able to take that pluggable thing, because it's just, I need state tokens issued by a particular issuer, and then it's a 51% majority vote. That's what I'm implementing. Someone's already done that. They did it better than me. I should just be able to plug that into my art auction, so that the vote for what kind of art am I going to show in the auction next month uses exactly the same mechanism. And I didn't have to grow it from scratch, because, hey, I'm not a governance expert if I'm building this art auction, right? And that's one of those things where we're going to get a real economy. We're going to be able to interface to the mainstream economy only if we can enable, literally millions of programmers to plug together those pieces to solve their problem, whether it's the next advance in DeFi, or whether it's, adapting to some, yet more important or yet at least more important to them requirement from sort of typical mainstream cooperation.
So I'm going to go there and ask you to unpack kind of the mechanism of recombination. But before I do that, what I wanted to actually kind of talk about is sex. Right. And the reason I thought that would amuse you, the reason why I wanted to go there is if you look at sexual reproduction, it's actually DNA recombination. Right. And the purpose of it from an information theory is really conservation and variation. Right. You have conservation and variation. So what you're doing is, and the reason why I think it's important to talk about in this context is if you actually look at it as an evolutionary strategy, it's very old. Right. Like, for example, like trees, if you go to a tree, right, trees have like flowers and they have like anthers and they have parts and they're doing sexual reproduction. Like trees are doing it. Like in my yard, there's like a male and a female like plum tree and they're doing it out there, and so my point is sex is as old as the evolutionary progenitor of humans and trees, right? So if you go back far enough, you're going to find the precursor. And the reason why I'm kind of going off on all this stuff is that...
It's to be provocative. We know that.
Yes, but I'm also trying to assert that sex is very, very successful, right? And the reason it's successful is the way that it produces and conserves a combinatoric variation, right? Which is that's exactly what you want out of a system, out of an evolutionary system. So coming back to like the essential nature of what you're describing, like you're absolutely describing, because conservation is really the thing of, well, that thing works, I want to plug it into my thing, but it doesn't work exactly how I want it, so I want to plug in my thing and then have it, so that's variation. So variation and conservation are like, those are the foundational building blocks for the, creation of the biosphere, right? And biodiversity, right? So I guess I want to kind of, throw that back to you so that you can kind of like help us understand kind of the essential nature of the combinatoric element of Agoric, right? Like what makes Agoric combinatorically sound and enables composition.
Mm-hmm. So the analogy of sex, ironically, is similar to the analogy of Legos, right? It's
very similar. Male and female Legos.
That's right. But
parts.
In object-oriented programming approaches, that particular analogy has been very important. There's people have looked at, there's the bionomic effort of figuring out how to do evolutionary systems.
Yeah.
But one of the things that the object approach does, and people thought about it a lot, built practices out of it, and then a lot of people kind of forgot about it, right? It goes back to this reinvention thing. It's that the thing that allows you to easily plug pieces together is you talked about a coherent protocol, but here it's the more narrow version of for objects. It's an API where the API is narrow enough, simple enough that multiple parties can implement it for their own purposes in some complementary fashion and plug these pieces together. So one of the really important underpinnings of the Agoric public chain smart contract architecture is the particular protocol we call electronic rights transfer protocol that is exactly an API for, in an object system, being able to actually talk about digital assets, right? I gave this example of a React, an amateur programmer now could do better than an expert 15 years ago because they have all those tools. Just having the native programming language, whether it's JavaScript or, God, people think WASM's a solution. WASM's wonderful, but now we're talking assembly language programming, so that's even lower level,
sure.
Right? But just being able to program is not enough. The reason they can do amazing UIs is because there are patterns and APIs to plug these components together, where the API for components in Reactor and Vue is a very simple thing that permits of lots of different variations for parent and children and components to come together. So ERTP gives you, instead of just here's JavaScript objects, well, great, I can give you a payment or I can give you a pointer to my window. Good luck with that, figuring out how much you got paid, right? ERTP provides the mechanisms and the metadata in the APIs, so I can hand you something and you can deposit it in, you can deposit a payment into your purse, and that only succeeds exactly if you now have exclusive access to it and it is the currency that you expected, and you've got JavaScript objects that can talk about the currency. And this gives you the framework in which the components you build can naturally compose and participate with other components. And so there's the first level is just, I can easily build a digital asset that my covered call can be across. So we have a covered call abstraction, covered call option that could be used where I could sell you a covered call that says you can buy my, ETH or my wrapped ETH brought over from Ethereum or whatever it is for so many DAI up until Thursday, and otherwise I get it back. Or it could be on a digital asset that I made, which is a concert ticket. Exactly the same covered call contract, only now the underlying asset is a concert ticket rather than a bunch of ETH, right? And the nice thing of that pluggability means now I can build any kind of asset, whether it's fungible or non-fungible, and I get to reuse that covered call. And then the next level up from that is now I can build smart contracts that let me do that. The ability to participate in a smart contract is itself a digital asset. So I buy from someone the ability to sit down at an auction seat, and it could be that it's an auction that you got to pay to get in the door. You got to put assets on the table. Now I've got a position in that auction, which is this ongoing thing that might take months, and it might have value. Think of seat on the stock exchange. I could now sell my seat, my place in this contract, whether it's an insurance contract in progress, whether it's a sale in progress, whether it's participation in the auction. That itself is another digital asset that I could wrap up in the same covered call and make available to someone else, right? Or I could put inside of a separate auction, and I could auction off my seat in this other auction, right? Or whatever it is, right? And if you don't think that happens in the real world, think about how people reserve Tesla, models in the latest model comes out, right? It's exactly the kind of arrangements that people come up with in an ad hoc fashion, and it works with these contracts because they're not trying to be the be all and end all of how you're going to interact with someone. They're a piece of that interaction that I can use and incorporate in some other process and combine together to have a richer contractual exchange with folks.
It's really amazing to hear, right? Because there's so many kind of threads that pull together as we see the emergence of these new environments, new programmatic environments, right? And extensions of kind of the paradigm of open source and the evolution of kind of blockchain and blockchain-based assets and the development of this, right? And evolution of it. Like some of the themes of some of the guests that we've had on the show, like Jake Bruckman from CoinFund was talking about the emergence of sort of an intellectual property respecting internet, right? And the idea is based on scarcity and not copy and paste, but rather on assets, right? And on licensable assets. And so you essentially get this kind of like IP sort of metaverse, right? That's commercial as opposed to being, so that's fascinating. Other themes that kind of pop up in this conversation, I had the Brightmans on, who are the creators of the Tezos blockchain.
Yeah, we know them.
They're very, very interested in kind of like foundational governance topics and kind of the evolution and appropriate incentivization of developers, right? So that's all of that stuff is super interesting, in how the blockchain, even the layer one can be like, subjected to an evolutionary paradigm, whereas in your world, it's actually the layer above that gets subjected to also an evolutionary paradigm, right? Which is, so to me, these kinds of primitives can result in the emergence of something extraordinary, right? Because another guest I had on the show was actually Kurt Braggett, who created a NFT game called Nifty Wizards.
I was watching that one earlier today.
I'm so glad, because what you allude to...
Oh, crap, he's got a demo. Do I have to have a demo?
No, but I mean, the thing is funny about that show is that he's alluding to NFT objects as actually serving as access control, right? So the idea becomes that there's a Telegram room called the Wizards Council, and you actually need to have a cryptographic wallet that contains a wizard staff, and there's only 15 in existence, right? And so if you don't have wizard staff, you don't get access to wizard council, right? And that's it. And all of that is done through cryptographic signature. So there's you can't fake it. Like you have a staff or you don't, there you are. And so I think all of these different layers are all kind of like part of this future that you're describing, right? And all of these kind of visionaries, I think, are all looking at these different dimensions of this, so it's very intriguing, and it's great to hear how deeply you're describing this architecturally, because you're really talking about the support of like Jake Bruckman's future universe, the multiverse.
Absolutely.
You're talking about Kurt Breguet's future universe. You're talking about the Brightman's future universe. Like, you're talking about a lot of convergence.
You mentioned Brightman. Kate Sills is one of our engineers who built a bunch of the smart contract framework, and she put together. I mean, I mentioned making NFTs is just as easy as making fungible tokens on our system.
Sure.
It's just a line or two of JavaScript code. So in one day, she put together a card store app where you could buy NFTs, and so. And then you could take those NFTs and use them with all these other components in the system. And so that's one of those things where, where I was looking at the Wizards Council application.
Yes.
And in terms of architecture, to me, there are sort of three classes of implementation of digital stuff. You talked about that all being crypto-based. There's a lot of crypto that people build that didn't need to be crypto. That it's really, if you designed it as an object architecture and that reflected downward in your infrastructure in a way that preserved the secure relationships and the secure objects in it, so you just built it as an OO system,
yep,
it would work just fine. So the Wiz example, the Wizard Council example with the Wizard staff, doing that in JavaScript and having that operate on our system would have all the right security properties. The Wizard staff is just an NFT. I allocate it. If I hand it to you, I hand it to you in a payment using ERTP. You take exclusive possession. Now I don't have it and you do. There's only 15 of them. We burn them. We throw away the minting authority. Now no one can mint anymore. Yep. I can now use that in a covered call, so I can sell it. I can take the covered call and sell it in an auction. The buyer could verify that it was a covered call of an actual Wizard staff that hadn't been claimed yet. All of those things can be done in JavaScript really efficiently. The only things that you need crypto for, and are the things where crypto is freaking magic, right? So one is signing of that initial strong proof that I have this key without revealing it.
Yep.
Encryption, where I'm doing that.
Yep.
And zero knowledge, right? Zero knowledge is magic that you can reproduce the patterns of, but in object, and that turns out the right way to surface it to a programmer, but it needs to bottom out in not encapsulating in an object the secret you're trying to protect, but in the chain simply not having that secret, and it's zero knowledge underneath. And so, hash commitment is a simple form of zero knowledge, but in general, zero knowledge is magic that you require crypto for. But many of the protocols that people build, if they just build them as objects first, then it's often clearer, it's easier to modify, or it's easier to compose, it's easier to define as an object protocol that lets people vary them much, much more quickly. So for example, we have an atomic swap. It's an atomic swap that'll work just fine with pegged assets brought over from Ethereum, with assets using transfer brought over IBC on Cosmos. Do an atomic swap in our contract, and then it all resolves, right? That works just fine and doesn't require the strange crypto that's currently required for non-custodial atomic swaps, between chains. And so there's some of these things where I wish people would start on the design first as objects so everyone can understand it, and then only bring in crypto magic when you really have A, an expert, and B, a desperate need for it, because crypto's hard.
It really is. It really is. And the thing that's beautiful is that, like, cryptography continues to advance, right? One of the biggest things that has popped up lately is indistinguishability obfuscation. I'm going to have a show with a cryptographer on that. And, the thing that does to me is it really enhances our confidence in cryptographic systems, right? Because, if we're able to establish that, then we're able to establish future systems like homomorphic encryption, and we're able to establish strong encryption, that I think can be durable, right? So I think to me, there is magic sauce here, and I think we are like rebuilding, the internet in a pretty fundamental way. So I guess what I'd love to have you unpack for me is, kind of more kind of an Agoric centric what's next, right? Because I'd love to hear kind of like, where is the Agoric project? I know there's tons of hackathons and there's people building exciting things. So, tell me what happens next.
So I mentioned this smart contract framework that to us is sort of the precious core of what we're doing. So we have an alpha of that out, so people can now actually start building apps on it. We are using that to build a crypto economy for an Agoric public chain next year. What do I mean by crypto economy, right? There's platforms for running smart contracts, but most real contracts in the world are long-lived, right? Subscriptions, mortgages, insurance contracts, all of these kinds of things are long-lived, meaty contracts where what I want is an environment that doesn't just let you run a transaction one time, and then when you do it in a month, the prices are just all completely different. I want to be able to run in a stable environment. My characterization of like gas prices on most chains is gas to me, the paying for execution is like postage. Every business needs it. But unless I'm really compute centric, my Amazon bill is not my primary business expense. My postage bill is not my primary business expense. Most businesses are doing things that are more interesting than that, right? And it's part of the cost of business, but it's not the central thing. On platforms like ETH, that's their primary way of extracting value, is to simply raise the price of postage, right? And you're paying with a volatile asset, right? So it's like I'm gonna pay a really expensive price of postage using Apple shares, right? Which is that just doesn't make any sense. So what we want is an environment where you can deploy dApps, you can deploy contracts where it is safe execution in a stable economy. So there is a consistent pricing architecture. There's a consistent, a consistent stablecoin in which contracts that might be plugged together and work together can all price things in a similar fashion. You've got an easy way so that if there's multiple sources of bringing pegged assets across, like pegged ETH, you can consolidate that. So you've got the ability to price it in a reasonably consistent single way and so forth. So this is a public chain based on Tendermint, nice battle-tested, best-in-class proof of stake mechanism with secure JavaScript with confined contracts executing in the most popular programming language on the planet, using this ERTP. So you've got this framework to be able to rapidly create and talk about and compose smart contracts and digital assets. And then frameworks above that, so you can safely compose them, safely roll out, safely, have lots of assurances to mainstream users that would be coming to this system afresh, to be able to rapidly develop interesting new applications. So we have the alpha of all of that. We're using it to build that economy, local stablecoin, a local currency, local AMM integrated into the overall staking architecture and execution and gas prices and all that sort of thing. And we will be rolling that out in 2021. So we're heading towards beta of that economy, and then we'll be going to a public chain next year.
That's super exciting. So to me, I think one of the things that's fascinating about what you're describing, I'd love for you to unpack it slightly, is like, everyone who's been doing Ethereum DeFi has absolutely been kind of subjected to these kind of wildly fluctuating gas prices, right? Everyone's using kind of ETH Gas Station, or they're using these apps to kind of optimize their gas usage, because the thing that's crazy about it is that it makes transactions kind of shift uncontrollably from being economic to being non-economic, right? So you have this really weird kind of effect, right? So I guess my question to you though is what we know is that this kind of postage model is actually it has an inherent self-protective quality against things like DDoS, right? So if you look, if you go back to kind of Adam Back, Hashcash, and the precursors to the Bitcoin white paper, you definitely get the feeling that people are paying postage in order to defend the network, right? And I think that's good. That's a valid thing, right? So how do you solve these concerns? Like what's the design center for Agoric's a stable gas policy?
Right. So that's a great question. It's not that that's not how you defend against DDoS, right? It's that on platforms where that's your only value extraction, right? In Ethereum, the way miners get paid is someone's paying gas prices, right?
Yeah.
I mean, yes, they're also minting, but that's a big chunk of it.
Sure.
Their incentives are aligned to find ways to raise your cost of postage. That's not a great place to live, right? The problem is not that the price of execution going up is a way to prevent DDoS. It's that there's so many actors with misaligned incentives with the customers that are actually trying to use this system to get work done, right? My prior project to Agoric and blockchain was a multi-billion-dollar payment instrument where it was a software as a service. In that system, right? I mean, a big chunk of what we were doing was paying cloud execution prices and paying physical mailing prices. And we had a budget. It did not vary by more than 10% a month. It was not 10x next month and half the price the following month, right? It was something, and it wasn't that we were bidding against a bunch of other people to get our work out. I mean, yes, the price would go up some if there was as cloud increased, but it wasn't like that was the primary extraction mechanism of our banking partners, right? And so we do have gas prices. They are based on, ironically, the auction defined in the original Agoric Open Systems papers. That's our fallback approach, because we know it has the right economic properties. And indeed, that auction, called the escalator algorithm, is either was or is being explored as one of the potential mechanisms to help fix the gas economics of Ethereum, right? So it's one of the proposals for that in future ETH and ETH2. I don't think it's the main contender, but it got people sort of thinking in the right way, like much of the Agoric Open System papers have done over the years. And so that, and then the gas price is not the way that we extract value to reward the participants in the economy, or the validators in the economy. One of the key things that you want is for the value of the staking token to you need to be able to how does the value of the staking token rise, right? In very few networks, it ties to the economic activity on the chain, right? In many networks, just like number of transactions, you're paying transactions, more transactions is better. The problem is that means a $5 million transaction is paying the same price as a $5,000 transaction, even though there's 1,000x the value there happening. And as you start to have 5 million and then 5 billion, pretty soon, the network value has not risen to provide any economic security that you require in a proof of stake system. Yep. Normally, you need the staking token to have enough value that people are not going to cheat, because the value they would lose in the staking token would be not worth cheating on the execution. That's the whole point of proof of stake, is you've got a stake that would be sacrificed. But if I'm going to sacrifice $1,000 stake for $1 million gain, it's not providing much of that security. It needs to rise in value with the value of the economy happening on the chain. And so the Agoric economic architecture, which I'm not going to go into detail here, but we will be talking about in December, and then starting publicly about it in December. And I'm happy to come back and talk about that once we are. But it ties the value to the staking token and to the stakers and the validators to the economic activity on the chain, not just the amount of messages you send and and your postage, right?
One of the funny things about the economic incentives that you describe is that, in a sense, there's an element of kind of like a protection racket element to this, right? Like, for example, if you understand the dynamics around something like a Chainlink, right? Like, Chainlink is exceedingly valuable, right? And the thing that's so interesting becomes this kind of almost like protection, or, well, I won't go as far as to say sort of racketeering, but there's a kind of a model where, because the thing that is interesting is that kind of an Oracle-based system is sort of a go big or go home model, right? Because what's happening is you're effectively providing staking as sort of a form of insurance, because without staking, there's no slashing, and without slashing, there's no safety, right? So like, if you look at a system like that, in a sense, like the system is almost forcing the economy to value it highly just so that it can even function, right? It's almost saying like, well, I'm not going to work unless I'm highly valuable, right? So it means that you're kind of saying like, go big or go home is what you're saying. So it's a very interesting thing you're describing, which is, you're basically saying the system should be going big or go home.
Exactly. Well, and, participants that are providing an economic environment for large-scale trade, I mean, you want the value of it to go up, but also, I want people incented to produce things that enable large-scale trade, right? If I'm, in order to get the $900 billion U.S. freight working on top of blockchain, so we can have increased value and reliability and all those kinds of features, it's got to be the case that someone is excited to do that, is well paid to do that, is well paid to make sure it has all the security and integrity properties you would want.
Totally
and
understood.
That means it's got to scale with the economic value being delivered. And so to us, that's crucial. I mean, that's what's driven the growth of economies and the growth of markets. And the hard thing was figuring out how to do it. And that's what we're very excited about for our chain was some people call it value capture when you're focusing on the investment side, but from a real chain system point of view, it's required for economic security.
Yeah, I love that, right? Because I think the thing that becomes so interesting is that it's part of the new era of pragmatism, right? Which is, I think that we've had, a form of purism that, kind of predominated the story, where it's basically like it used to be secure or nothing, right? And if you actually look at something like a Chainlink, the idea becomes that if the bridge keeper somehow collapses the bridge while your truck is on it, right, then the penalty for them doing so is so high that so the mindset of pragmatism is basically, I'm willing to roll a certain dollar value of trucks and inventory across your bridge just because I'm aware of how painful it will be if this fails, right? So to me, that's a very kind of a proportional and economic calculation as opposed to a cryptographic calculation, right? It's not about intrinsic fundamental security like proof of work. It's actually something that's a little bit more just pragmatic, like what do I think you're going to do? I think what you're going to do is based on how you're being paid.
Right. Well, and I'll tell you another reason. So we have we announced our partnership with, or collaboration with Chainlink, and we're doing a hackathon right now with them. But so they'll be a launch partner, and I'll tell you some of the key things that are pragmatic but surprisingly different, related but different from what you just said. A long time ago, I sort of characterized hard problems in sort of two dimensions, right? The one we're most familiar with is what I call deep problems, where like implementing a blockchain, or implementing, a database engine or a payment instrument or whatever, those are hard, and they're hard where you're limited by the complexity that humans can manage, and use encapsulation and modules and project tools to be able to build these systems that are testaments to innovation and really powerful and have these nice properties to them. And that's what I call a deep problem, where the encapsulation and so forth works. And then there's and my example of this is payroll. But I'd almost put oracles in the same bucket, where I mean, it's not that oracles are, oracles, when you actually go look at them, they're harder than you think, let me tell you. But they look pretty straightforward, or at least the first one does for the first week. And then something changes, and now you need to change that. And then you want the second one, and the second one is a little bit slightly different. And then something changes. Does it change it for both or only for one of them, right? And then you want weather oracles, and they're a little bit different. And and so it's one of those things where this is what we call a broad problem, right? Payroll of, I take your salary, I multiply it by the tax, and that's how much you're going to divide by the week, and now that's how much you pay. That's pretty easy. The problem is the tax is different in every state, in every jurisdiction, in every month, in every zip code, right? And, except for Thursdays, and once in a blue moon, right? And the maintaining of the details is a different kind of hard. It's a broad problem where the things that made deep problems work, like encapsulation, get in the way of your broad problems of managing all of the details that you have to keep straight and keep up to date. And so the Oracle problem obviously has its deep parts, but it also has these broad parts of wanting a breadth of numbers from a breadth of sources with a variety of changes that are happening differently for each of these oracles. And I want a community of people that's keeping track of all of that, because that's just not what I'm good at. And that's just not what I'm good at is a really important thing there, because the thing that having someone else solving the Oracle problem does is that fits into our Lego model, right? Where I don't, any problem, any particular implementation thing I could do, but if someone is already doing it and doing it potentially better than I could do it, I am well advised for time to market, safety, maintainability, all the usual reasons why people use components. I want to be able to grab a price oracle, plug it into my contract, and go, right? I want to be able to take my call spread, which has a place to plug in a price oracle. Now that goes back to your, sex and oracles, right? There's an API that we defined as part of preparing for this hackathon of here's where a price oracle fits in, and here's the Chainlink implementation of a price oracle that lets you interface to Chainlink nodes over there. So now they can plug and play and manage themselves and do whatever they do to maintain how it is they get me good data. I can fit that in here where it now just plugs in a JavaScript component, and we did all the plumbing underneath together with them so that when we launch, we'll have an information-rich environment with these pluggable pieces. So just like I can plug in a call spread or grab an auction or whatever, I can grab a call spread and plug in this particular price oracle that I agreed on with my customer and sell it, even though I could not have implemented that price oracle. I could have not have cut those deals with the price sources. I don't have the right set of keys, and I'm not going to be able to maintain it over time so that the price oracle is still delivering a good price in 6 months.
Yeah. So what I love is the emergence of pragmatism, right? And the reason why I love the emergence of pragmatism is, and I've always loved this about Agoric and the company culture, the history, the philosophy, right? Which is that, like, one of the great conversations, I had with Markham was this kind of notion that, like, most of the transactions in the universe are things like grocery store where there's not really this kind of like contract, like, you might sign a credit card statement, but if you use cash, you're not signing a contract that says, give me that orange, I'm willing to pay you $1, right? Like there's no contract. It's just loose. It's loosey-goosey, right? But the thing that's really, really cool, obviously there's a protocol and coordination, but the thing that I think is really important is that when you get back to pragmatism, the thing that's so interesting is that it's flipping back to full circle, right? Because I think that, in the beginning, there was kind of like money, and money was a protocol, and people are kind of like looking at this money and they're like, okay, well, how do I know it's worth $1? And then that kind of went from like 100% reserve with like redeemability to fractional reserve to no reserve, right? So now we're kind of all in this weird kind of like what the hell zone, and Satoshi shows up with his provable thing.
I said so.
Right. And so Satoshi comes in with hard money and he's like, I've got hard money and it's provably scarce, here you go. But the thing that I think is so exciting about this kind of flip-flop kind of this tendency is that ultimately when it comes down to kind of commerce and economics, right, the thing that's so interesting is that you actually want financial assurance again, right? In other words, like if you live in, because the thing that's dangerous about code is law is that it assumes that the world is perfect, which I think it's right. Cause like you always have to have, what if it all goes to hell in a handbasket, right? Like, like where are we going in this handbasket? It's like, well, we know, right? Like the world always is flawed, right? So financial assurance is the process of like having the law be law, right? So I think that that's when you're going to see the floodgates of these more enterprise cases that you're describing, right? Which is at the end of the day, if the thing doesn't do what it says on the tin, someone's going to step up and take care of business, right? So I think, and that's when the companies will come. That's when the enterprises will come.
Well, the other thing on the code is law thing, right? I'm not, that's not one of the phrases I care very much about.
Yes.
Law is often the rules that I get to assume that someone else will enforce. And so when I've got smart contracts doing the enforcement, that's the enforcement that happens. It's not about law. It's about this is what it's going to do. Do you want to call it law? Now we're talking semantics. I don't care. Whether I care or not, this is what the code is going to do, and this is what's going to happen. Right. And it's nice to be able to kind of have a scope where I actually know all of that. It's not a matter of precedent. It's not a matter of argument. It's a matter of, yep, that's what's going to happen. And I like that. That's the coordination I want with you. Let's do that.
Yeah. So
more voluntary cooperation in safer contexts.
Yes.
The more safety I can get with voluntary cooperation, the more voluntary cooperation there will be. And I like a world with more voluntary cooperation.
100%. And what I'm really poking at is I'm poking at the idea that automation produces a kind of like much more orderly and a much safer, world, to process transactions and to kind of conduct commerce. But the thing that always is true of all human endeavors is kind of until it doesn't. Do you know what I mean? Like in other words, like, and we've been seeing it. We've been seeing the pain of it in DeFi, right? Because
governance, you know,
and you know, one of the exciting things that people are arguing about is they're arguing about these flash loan attacks, right? Because the flash loan attack is everything's working beautifully. Everything worked as intended. The guy walked off with like $7 million that he didn't like earn, but like you could say he earned it. He earned it by like doing this flash loan, right? He punched the other guy in the mouth and then he like took his lunch money, you know, and that's is, you know, so people who don't think that's an exploit and don't think that's hacking, you know, their code is law people. But I would say this, right, is that I agree with you that that's a thing, but I think that it's a lot like the assertion that there's no difference between theory and practice. In theory. Right? In theory, there's no difference between theory and practice, right? But in practice, there is, right? So,
so I used to do a lot of computer security, you know, brokerage, Microsoft, Sun, you know, and I kind of got out of it for a while because it was a thankless task, right? My perspective on security is with a more secure system, it enables you to do things that you were not able to do before, and so I want to focus on the things it enables. And that's in tension with what a lot of people do is they do things in an insecure environment that they're just barely getting away with. And now you're competing with enabling the things that people think they're already able to do, even though they desperately shouldn't be, and they're going to get burnt. Right?
Yes, I love
and
that.
So I stepped away from that. And one of the things that is, I won't say fun, but a characteristic of the blockchain environment is that, yeah, you don't get away with it, right? Partly because of the Byzantine nature, you know, this, I don't know, you sort of ascribed it to the code as law folk. I don't think that's quite how they think, but just the, you know, if I was able to take your code and do something that got a bunch of value out, then that's fair game because that was what the code did. I don't actually subscribe to that position, but the fact that it is a hostile environment for code means all of the expertise we have around how to actually deploy systems in which it is safe to have code cooperate so that the hostile actions are mostly impossible. You know, suddenly those are rewarding because it's, you know, you can just point at places where, yeah, you didn't do it there and you lost $200 million, right? You didn't do that and you lost $25 million. And it's no longer, you know, it's no longer the model of, so you apologize to your customers, promise you'll do better, and then you apply the same tired best practices that clearly have not worked for the last 25 years, you know, in general, and you move on. And yeah, that doesn't work in blockchain. Right, you know, the punishment is sufficiently quick that the accountable parties are still there, and sufficiently brutal that the costs are such that you can't sweep them under the rug. And so we really do need all of this technology that people have built in a variety of different places for providing actual safety and security in order to be able to rapidly innovate. And so, you know, having a platform that brings all those together is exciting, but we're also excited. I mean, you know, you talked about the innovation in crypto. I mean, you know, 2019, 2020 was the year of zero knowledge, man. I mean, all sorts of innovations rolling out in all sorts of environments. Huge win for our ability. You know, it's 90% of the lift towards systems that can give privacy. Now the people that want to deliver privacy only have to do the last 10% rather than having this giant lift. And so it's just a huge step forward for the overall community across a bunch of these security technologies that'll let us do yet more cooperation, collaboration, and smart contracts. So.
Well, and I think that's the greatest thing of all, right? Which is that there's a phrase, you know, it's common in U.S. political parlance, which is this kind of effort to seek a more perfect union, right? And I think, you know, in a way, the evolution of things like open source software have been that, and the kind of inherent cryptographic security of open source software versus proprietary software, you know, is people used to think that security could be obtained through the obscurity of proprietary software, right? Whereas, you know, that's just been disproven time and again, right? So I think what you're alluding to is absolutely fair, right? Which is that, you know, these systems are still young and we're going to keep growing and they're going to get more and more asymptotically perfect, right? But I think at the end of the day, like, there's always that marginal imperfection somewhere, right? Because that's human endeavor. And the thing that's interesting is the greater the rewards get, the more clever the hackers get. And, you know, so I think that, like, there's always this kind of incredible arms race to produce those exceptions, right? So that's what I'm really kind of talking about in the end, is that, like, you know, the systems will continue to push out the number of nines in terms of the cases in which it will work perfectly, right? And that's great. Like, that's a beautiful thing to be optimistic about.
Yeah, I would like to though point out that the real innovations are step functions. You know, yes, we can talk about an arms race at the grand scale, that's true, but you know, software engineering proceeds with new safety properties where once we got memory safe languages, you know, 80% of the bugs of dangly pointers simply were gone, right? It wasn't that they moved. It wasn't an incremental change. There was an incremental change from C++ system to Java and C# systems and JavaScript systems. But the difference in the class of bugs that happened on those memory safe systems versus the ones that didn't is just night and day. And so we have the same thing that we need to do in blockchain with these step functions that really deploy new architectures and technologies that are night and day changes in the overall safety of what you get, so that we're now, you know, yes, it's an arms race, but it's an arms race in a new, safer environment. And now we're not throwing nukes, we're throwing snowballs against snow forts, right? And our overall level of safety is just generally gone up, even though someone could pack an ice ball and whack you in the head, right? I mean, it's one of those things where it looks like the same game, but it really is a night and day difference.
That's beautiful. Yeah, and so, you know, what I think I'm aware of is that, like, you know, these are always incredibly exciting and rollicking conversations. You know, I think I'm gonna have you back on the show because you know, I think we're gonna have to put this one in the can.
Good.
Thanks so much.
Thank you so much for the time. Thanks.
Really enjoyed it. Talk soon.
Bye, Miko.
Bye.